guys, how's it going? Okay, so this actually starts a hodgepodge of chapters. This you could say is about 10.3 in the book. And we're going to talk about parts of the radical. So what I want to point out first is this part, this n, that's known as your index. So it depends on if you're raising it to the square root, which is typical, the cube root, the fourth root, the fifth root, so on and so forth. So the nth root of a number, a, here's our number, can be written as the radical expression n root a. And this symbol right here that I'll just kind of highlight in green, that's called your radical. And this portion right here that I will circle in purple, oops, that's not the purple that I wanted, but oh well. That's called your radicand. Radicand. Okay, so the number, whatever you're taking the root of. If there is no index number, so if there's nothing up here, it's assumed that n equals 2. So technically like a square root. We don't usually write a 2, right? But like a square root. Say it was the square root of 9. We would know that that was 3. So let's go ahead and list 15 perfect squares just so you know like what they are. The first one is 1. Then we go to 4, which is 2 times 2. And then 9, which is 3 times 3. 16, which is 4 times 4. 25, which is 5 times 5. 36, which is 6 times 6. 49, which is 7 times 7. 64, which is 8 times 8. 81, which is 9 times 9. 100, which is 10 times 10. 121, which is 11 times 11. 144, which is 12 times 12. 169, which is 13 times 13. 196, which is 14 times 14. And 225, which is 15 times 15. Hopefully your parents made you look those up when you were younger or memorize them, or actually your teacher, hopefully. Okay, so what I like to think of when I'm doing a perfect square is I ask myself, what is the biggest perfect square that can go into the number that we're taking the root of? That can go into the number. And keep in mind, this is the list of all of our perfect squares up to 15. All right, well, if we look here, we would see that, 64, that's a perfect square, all right? And we know that that's 8 times 8. Whenever you see a pair of numbers like that, they actually get to escape. Think of this as like a little prison. They get to escape the prison. So technically, the square root of 64 is simply 8. All right, the square root of 121, if you look up here, that's another perfect square. 11 times 11. And look, we have a pair. So they get to escape the radical prison and becomes 11. Right here, we have a number on the outside. Just ignore this number for now. And let's take the square root of 9, which is 3 and 3. So we have a pair and they would get to come out of the prison. Anything that comes out of the radical prison, in this case would be a 3, gets multiplied by what's ever out there. So 14 times 3, and you would end up with 42 as your answer. Whoops, I'm forgetting to box all my answers. Let's try to make it a little bit easier for you guys. Okay, same thing here. We're just going to ignore that negative 3. From now, we're going to take the square root of 36, which is a 6 and a 6, perfect square. So now we're going to think, negative 3 times 6, that would give me negative 18. And that's my answer. Okay, well here is a little bit different. It's the square root of 64 and the square root of 25, 25 on top. We'll just break those down separately. Go ahead and do the square root of 25, all right, in which you would get 5, right? That's a perfect square. And do the square root of 64, for which you'd get 8. And then you can simply write it as that fraction after the fact. Your numerator, which was 5 on top. Oh, I'm writing it all green now. I only meant to do that for a couple problems. And 8 on the bottom. So why don't you guys try it really quick? Pause me and try number 6. Okay, and if you need more help because you're still a little confused, that's fine. We're going to do the square root of 9 over 100, which the square root of 9 is equal to 3, and the square root of 100 is equal to 10. And that would simply be our answer. Okay, so now we're going to move along and list the 10 perfect cubes. So if we do that, well, 1 is our first one. 1 cubed is 1. 8 is our second one, which is 2 times 2 times 2. So that is like a number times a number times a number, if you're wondering what cubed means, right? Cube means three-dimensional, right? A cube. Okay, and then our next one would be 27, which is 3 times 3 times 3. And then 64, which would be another one, 4 times 4 times 4. And 125, hold on, let me get my handy dandy whiteout. 125, which would be 5 times 5 times 5. And then we have 216, which is 6 times 6 times 6. 343, 7 times 7 times 7. 512, 8 times 8 times 8. 729, 9 times 9 times 9. And 1,000, which is 10 times 10 times 10. Okay, so if we look up here, we see that, we're now taking the cube root of things, right? Unfortunately, right here, this is to the cube root, and we know that 27's a perfect cube, and that it's actually 3 times 3 times 3. Remember when we were squaring how we needed a pair to come out of the radical? Well, this time you need a set of 3 to come outside of the radical. So this would simply be equal to 3. All right, 125, if we look, that was when we cubed 5. So you would have a 5, and a 5. And again, we have a set of 3, so it can come out of the radical. And then we move along down here. And you guys might panic a little bit like, it's a negative. But that's okay. You can take the negative because it's a cube root, right? So if we look at our order, 1, 2, 3, 4, we see that that was 4 times 4 times 4. But the big thing is that it's negative. So if it was negative 4 times negative 4 times negative 4, we would still get negative rad 64. And it's a pair of 3, so it can come out of the radical. And then over here, we might panic a little bit again because we see, oh gosh, it's a negative, but fear not. We're going to go ahead, and we know that 2 times 2 times 2 is 8, but they have to be negative. Negative 2 times negative 2 times negative 2. And again, we have a set of 3 that can come out, and our answer would be negative 2. So this is all if they're perfect, right? Perfect squares, perfect cubes. What about if they're not perfect? So when we move to our next sheet of notes, we'll see that we have some not perfect squares. So like I said before on the last paper, find the largest perfect root that is in the radicand, meaning inside that radical sign, and is divisible by. And then break the radical down using the largest perfect root. Take the square root of the perfect square or cube or whatever it might be, and leave the leftover, whatever couldn't come out, under the radical. If there is a coefficient outside the radical, multiply this with any number you take out of the radical symbol. Okay, so let's look here. Let's look and see what's the biggest perfect square that can go into 12. Well, 4 would be the biggest perfect square that can go into 12. And 4 times 3 is 12. Well, 4 is a perfect square. What's the square root of 4? If you don't remember, just think of something. What multiplies to 4? Oh, that's 2 and 2. Oh, that has a buddy, so that can come out of the radical. But this guy, this 3, he's left over. He has to stay in the radical. He's stuck. He doesn't have a buddy to go outside and play. All right, so let's look over here. Let's look at the biggest perfect square that can go in to 24. And the biggest perfect square that I can think of is 4. 4 times 6 is 24. Well, you know that the square root of 4 is 2, so you can bring that out. If you're a little stumped on how I got that, it was just 2 times 2. And since we're taking the square root, since there's no symbol there, I just need a pair to come out. And now we have a 2 and a 3. Well, there's no pairs to go with those, so they have to stay inside of the radical. So 2 times 3, which is technically whatever stays in there gets multiplied. So 2 rad 6 would be your answer. All right, now let's look over here. What is the biggest perfect square that can go in to 48? Well, I got 16 and 3. So the square root of 16 is simply 4, and then 3 can't be factored anymore, so the 3 would stay inside, and that would be your answer. If you're a little stumped on how I got that, like, oh, 16, what if I didn't get those factors? That's okay. Let's say you did 48 and you decided that you were going to use 6 and 8 because you couldn't think of a big enough perfect square. Well, 2 and 3 are the factors of 6, and 8 would be 2 and 4, but 4 can be factored to 2 and 2. So now look, guys, because I'm taking the square root, I just need a pair to come out. That would be one set of 2's would come out. And I need another pair to come out, this set of 2's, and they would come out. And then this poor 3 is a loner and he's left all by himself. So 3 stays there. Well, whatever came out has to be multiplied. So 2 times 2 is 4, and then 4 rad 3. Okay, hopefully that's making sense a little. And then we will do 63, which is 9 and 7. All right, well, the square root of 9 is 3. All right, which I didn't have to factor that out, but I just went ahead and did it anyway. So that little buddy, the pair, would come out because it's still square root. And then the 7, which can't be simplified any further, would stay inside. And I just dropped my pen. Okay, so these are square roots. And notice they don't have a 2 above them because we just assume, well, we know that they're square roots. This gets a little bit trickier right here where you see that there's a cube root. So while you're getting used to cube roots, it might be a good idea for you to keep the list that we made of perfect cubes. And if I'm looking at my list, I see that 8 is a perfect cube. And 8 and 5 multiply to be 40. So if I were to take the cube root of 8, I would see that that is 2 and 2 and 2. All right, in order to come out of a cubed radical, you need a set of 3. So the 2 would come out. And this 5 that's a loner, again, Instead of just one buddy, he needs 2 buddies, but he doesn't have any, so he stays in. So he is 2 rad 5. All right. Same thing here. What is the biggest perfect cube that multiplies to 192? If you can't think of any, just look at your list again, and you can try dividing by those numbers. Divide by 8, what do you get? Divide by 27, what do you get? Divide by 64, what do you get? That's totally fine. A little guessing and checking never hurt anybody. So 64 and 3 is what would multiply to be 192. So 64 and 3. And I know that 64 is a perfect cube. I know that that's 4 times 4 times 4. So I have my set of 3s that get to come out. So 4, here it goes. And then this 3 that's just this little loner and has to stay in, stays in by all by himself. So that's it. I am telling you that this chapter is a bit of a hodgepodge. It's just 3 little videos and then some homework, and then we'll follow it up with a quiz, and then we'll move on to the quadratics. But I hope you guys are doing well. I hope these are making sense. Please come to office hours, Tuesdays from 12:30 to 1 for algebra. Reach out to me if you need additional support. Maybe you and a couple friends do. I'm here to help you guys. I just can't read your minds, so you have to talk to me. Okay, bye guys.